I usually begin a workshop by saying something about myself, and I begin by saying, you know, I was 5 years old when my grandmother was born. I can't say this to you because you guys know this already, right? So the fun is gone, and I shouldn't have sent that chapter to you. Now I realize I made a mistake, but it doesn't matter. So there are a few things that we said in that chapter at the beginning. One was, somebody called it John. John was 5 years old when John's maternal grandmother was born. And one of slightly simpler would be, John's mother never had any children. All right? Which all of you recognize as cannot be the case. Okay. Here is an instance where you already have the knowledge. You already know that it is not possible for any mother not to have any children. So why ask the question?
What if John is an adopted son?
Yeah.
But
so
it was specified.
It was specified.
pardon me?
It was specified.
Yeah. It was the question was in in the notes, in the chapter. John's biological mother never had any children. That was the proposition which all of you regard as false. Okay. So the task given to you in the chapter is prove this. Prove that it is true. You know this is true, but that is not sufficient. You have to prove that it is true. Okay? You have to begin. Yeah?
And it's not possible.
Prove that
It's not
for
possible.
no mother, doesn't matter who it is, it cannot be the case that there is a mother, biological mother, who never had any children.
You need to define mother.
Okay? Fine, fair enough. So you define. Okay. So now you should know that what you're learning is how to construct definitions and how to evaluate definitions. All right. Okay. Let me have a definition of biological mother. Who wants to suggest one? Okay. What I suggest is 3 of you sitting next to each other form groups of 3. And if you can't, doesn't matter. I'm not going to insist that there should be only groups of 3, groups of 2 or 3. Okay, that's possible, right?
Yeah.
And suggest definitions. Who is your group member? Who are you? This is your group? The 3 of you. Good. Alright, this is just a very simple thing. I'm not asking you to define something complicated as entropy. This is just your biological mother. So, this much time is more than enough. Okay. Alright. Which group will give me a good definition? Which one? I see. I have to see some hands, otherwise.
He raised his hand.
A female who is biologically related to a son or daughter is a biological mother.
Let me wait, hold on. Let me write that down. A biological mother is a female
Who is
biologically related
to a son or daughter.
Wait. No. Hold on, no, let me write this. Yeah. So I need to understand this. Biologically related
To a son or daughter. Whatever.
to
To the child.
Okay.
daughter.
I thought to read.
Did I write your definition? Do you want to change it?
No.
No. Okay.
Read a bit.
Who wants to say something about it?
An aunt can be related to someone else. Aunt can be related to her sister's daughter or son.
But she is a mother, not the aunt. The answer is
But you say that
Hold on, wait.
female.
No,
It's a
wait.
female.
Here, there are some rules of the game, okay? Only one person speaks at any given time. Alright? If 5 people speak, it's going to be chaos. So one way of making sure that only one person speaks is raise your hand. Okay, who wants to say? Who wants to speak first? You or you? So raise your hand.
Okay, he defends himself and then I argue.
Okay. You have to defend yourself. You think you don't have to defend yourself?
No, I'm there with my answer.
You still stick to your answer. Okay?
Okay, now aunt is also related to someone's son and daughter. He hasn't specified the female who has given birth to the
To
son.
her. Sorry.
Yeah. Go ahead.
Yeah. So any female can be related to anyone's son or daughter with different relations. Someone can be a parent's sister or sister-in-law, grandmother.
Okay. Let me help you a little bit. Normally I do not help students. But I make a special exception on Mondays before lunch. Okay, that's it. After lunch, on Monday, the rest of this week, no help. So let me say this. Suppose you say X is Y's aunt. Now let us ask the question, are X and Y, and X is a female. X is a female and X is related to Y. Is X related to Y?
Yes.
Is X a female?
Yes.
Is this definition satisfied?
Yes.
Yes.
Is X the mother of Y?
No.
You see the problem? No, wait, hold on. You see the problem? The problem is the following. This is a counterexample. Okay? So if you agree that in this situation, X is Y's aunt, and aunthood is a biological relationship, then you're forced to say an aunt is a mother, which you don't want to, right? Those are the kinds of things that we call counterexamples. So we are going to use words like counterexample and counter-evidence in a process of inquiry, also in learning inquiry. So this is a counterexample. A counterexample is an example that logically contradicts your definition. So when you have a counterexample, there are 2 options you have. Either say, this is not a biological relationship. That is possible. You can say, aunthood is not a biological relationship. Then of course somebody will ask you the question, why is it not a biological relationship? But you have that escape. If you don't want to say that, then you have to change your definition. So everybody agree that you have to change this definition. All right, give me a different definition. What I want you to do is to construct a definition of the following form. X is Y's mother if
Conditional.
do you know this word?
If and only
If fantastic. Okay, you guys already know this now. If and only if. That part you fill in. I've given you, yeah.
If and only if X has given birth to Y.
X has
given birth to one.
given birth to Y.
Test tube.
But yet it is
It is
the
still
child-
given by biological
Yeah.
mother. It's still considered as given. The lab technician is doing everything, right?
No, but she has given birth because she has.
Who uses
Well, what you mean to say is, now you have to define.
given birth?
Okay. This is a general characteristic of definitions. In order to define something, you use certain words, and somebody is going to ask you, what does that mean? And then you give another definition. And then somebody is going to ask you, what does that mean?
Goes on and on and on.
Unfortunately, that at some point somebody gets tired and say, okay, go ahead. Right? Not really. I think when everybody feels that things are clear, even without a definition, then you say, okay, intuitively somehow I understand it, I don't want to question further. At some point you have to stop. And there's a word for such constructs, I'll come to that later. Assume for the moment that we all know what this means. Right? Giving birth would mean somebody carries this, the embryo in the womb, and delivers, etc., etc. Somebody gets pregnant, okay? And you can define pregnant as somebody who looks like me. So I need a definition. X, so that I'm going to say Y is X's biological child if and only if, okay, now I stop.
Same thing.
If X has given birth to Y. Again.
Yeah.
Okay, if X has given birth to Y. If you put together these two definitions, what is the consequence? What is the logical consequence of these two
X
propositions?
is Y's mother, then Y
Y
is
is
Y's child.
Right. If X is Y's mother, then Y is right, and reverse, both ways, right? Okay. So let me write that down. This is the logical consequence. There is no way of avoiding this. Okay. And that is if X is Y's mother, then Y is X's child, biological child. And if Y is X's child,
Then X
Right.
is. Then X.
exactly. So is it possible to be a mother without having children? No. All you have to do to prove this is to come up with the definitions of mother and child. The proof is simply define, and the logical consequence is the conclusion that you want to prove. This is something that you have learned when you try to construct definitions. Chances are that in your first attempt, it will be faulty. There will be some flaws. Then you fix it. Then there will be some other flaw. Then you fix it. Can you be completely certain that your definition is completely flawless? No. So we are not looking for perfection. Okay. We have done that. Now can you do the grandmother thing? Suppose I tell you, my maternal grandmother never had any children. But I haven't said anything about grandmothers yet.
So define grandmother.
Yeah.
Define grandmother, okay.
Biological grandmother.
Biological maternal grandmother. What's the definition?
Z is
X's.
Y's
X's.
Z is Y's grandmother.
Z is,
Z is a female who is Y.
X. Let's make
Well,
it
wait.
first. Let's make them all Y.
I get very confused when more than two people are talking. Alright,
Z is Y's biological maternal grandmother.
Y is biological maternal grandmother if and only if.
Only if it is she in the sense she's a female, so
Z
Z.
is a female
female
and
has given birth to X.
Who's Y's
Who is Y's mother?
Biological.
has given birth to,
X.
Who
has
has given birth to Y?
given birth
X.
to,
X.
Who has given birth to Y?
Yeah, who has given birth to Y? Or you can say who is Y's mother.
Y's mother. Does it work? If all of you, if you cannot find any flaw with this, we'll accept this for now.
Biological grandmother.
Oh, yeah.
Okay.
Yeah.
Should I zoom?
Okay, now you can see easily that given these three definitions, definition of
Okay.
biological mother, biological child, and biological maternal grandmother, it would follow that cannot be the case, right? There cannot be a maternal grandmother who hasn't ever had children, because that follows from. So this is also a case where the proof follows from the definition. That's all that you need. In many cases, once you define something, certain consequences will follow, and that's what you want to prove. What about this? I claim
Madhu sir is not there.
okay?
I went there for a while.
I'm making a claim that I was 5 years old when my maternal grandmother was born. So let's go back. How will you prove to me that it cannot be the case that my maternal grandmother was born? When my maternal grandmother was born, I was 5 years old. Again, since today is my generosity day, this morning, I'll give you a clue. Definitions are not enough. Okay? You also need an axiom. An axiom is something that you take to be true without a proof. That's a starting point. Okay. Sometimes there are self-evident. What? Do you know this term, self-evident?
Yes.
Okay. Some axioms are self-evident. That is to say, when you look at it, you know it is true. It is obvious that it is true. You don't have to prove it. There are also axioms which you accept as a starting point, and you don't care whether it is true or not. Okay? So Euclid thought that all his axioms were self-evident. It turned out that some of them were not self-evident. So I want you to construct an axiom such that you can give this proof. Let me give you some time to think. Talk. It's crucial that you talk to one another. If you do not talk, you are not getting something out of this course. Right. Everybody ready? Okay, I want somebody who hasn't said anything so far. Who is it who hasn't said it? You have said something, you have said something. You haven't. Okay, your chance.
A mother cannot be younger than her child.
A mother cannot be younger than her child.
A biological child.
I don't quite see why that should be so.
Okay, addition.
Hmm?
Like, slight change.
Slight change, okay.
She has to be in existence before a child, before giving birth to.
Okay, so in order to give birth to somebody,
You have to be.
you have to exist. Ah. Is that self-evident to me? That is true. Nobody can give birth to somebody else without existing, right? Yeah, I don't. I'm thinking of ways of finding flaws with this. Let's see. Let me try, okay? If I don't succeed, then I'll accept it as obvious. Anybody? Can anybody find flaws with this? Okay, the way to think about it is look for a counterexample. Okay? Can you find a counterexample to this axiom? I can't. Okay, so shall we accept it? Alright, for now let us accept this axiom. Can you state the axiom?
A mother cannot exist before her child. Oh, sorry.
Give birth.
Has to
X
exist to give before her child.
cannot give birth
Without existing.
to Y before X exists.
Yeah.
Alright? Of course, giving birth to somebody is making that person exist.
Yes.
So I have to exist before I can make somebody else exist. That seems to be okay. But my proposition was, I was 5 years old. I'm not able to connect this to the business of being 5 years old. Wait, hold on. Somebody who hasn't spoken yet. Who hasn't spoken?
He hasn't spoken.
Somebody who hasn't spoken should. Okay.
If X exists, then X surely has some age.
Okay.
Biological
So
age.
if X exists before Y, then X has to be older than Y.
Yeah.
Okay. So a consequence of this will be, if X exists before Y, X is older than Y. Okay, so what I said was, I was 5 years old when my grandmother was born. If that is the case, I must be older than my grandmother. That cannot be the case by this. Okay, so what you have is a proof with a number of steps. You have these three definitions, and you have these statements, and you can now step by step prove that it cannot be the case that I was 5 years old when my maternal grandmother was born. Okay, what I have shown you is a way of mathematical thinking, a way of constructing mathematical proofs. But the subject matter is not mathematics. Right? Mathematicians normally don't talk about mothers and grandmothers and so on. But can, in fact, it is possible to construct a theory of mathematical theory of relationships. But they haven't done that, that's all. And therefore, you didn't have to study it in your school. Right? But the thinking process is what you find in mathematics. And if you understand this, then you understand the proofs that you have to learn in mathematics. What did you learn from this exercise? Mothers and maternal grandmothers and so on. You obviously didn't learn about mothers and maternal grandmothers, right? So what did you learn? Yeah.
We learned how to prove statements. First way that I think we've learned is by counterexample.
Yeah.
If we know that something that contradicts the statement given has already occurred, like we have an example, then we can state that to show that this, we can disprove something by counterexample.
Yeah, you learned how to disprove something using a counterexample. So that the concept of counterexample is very important. Okay, what else did you learn?
Then the other way that I've learned for proving something is first we can define something, and on the basis of that we can form some logical consequences that will lead us to
That will be a proof. So you learned one way of proving using definitions.
Yes.
What else did you learn? Yeah.
We learned how to take certain statements as axioms, as self-evident and as a starting point, and then from it to build up on those axioms up to the statement
that you want to prove.
Prove or disprove.
Yeah. So you learned not only how to prove something using definitions, but also how to use definitions and axioms to prove something. Mathematical proofs are essentially of that type. Use a combination of axioms and definitions to prove something. Of course, once you've proved something, you can use that result to prove something else. So you can gradually build up. Right? I wrote the word disrespect. That's a kind of emotionally laden word. It's a little strong. What we mean actually is this: intellectual skepticism.
Yes.
That is the attitude that says, I'm not going to believe what you say unless you give me rational justification. I won't accept it just because you are a teacher, just because you are an authority, just because it is there in the textbook, and just because you are my father or mother. Don't tell this to your parents. Okay? No authority. We are not going to accept any statement just because it comes from some authority. Okay. This is an essential characteristic, a central characteristic of rational inquiry.